Okay, everybody, we're going to do some questions from the 4.5 homework assignment, starting on page 301. And one of the questions that was probably asked for the most was number 31, and my guess is probably because you haven't seen a slope field yet. We are actually about to, like after this next test, we're going to be doing a unit on differential equations, and it's going to have a lot of slope fields in it. But basically the slope field just shows you all the possible, like, options of solutions for this equation. So this is a derivative dy dx. So the particular solution would be like whatever y equals. And so this is kind of showing all the possible little slopes. And so I think the first thing it said was like sketch two different ones that will pass through that point. So I could potentially see there being one kind of like this. Sorry, that was supposed to be connected. So like there's an option right there. Another option might be one that like goes down lower, like maybe one like this. So that one's like really, really rough. You don't, I mean, I wouldn't worry about it too much. We'll get into that more. But the second part of the question was use integration to find the particular solution of that differential equation. So let's actually solve that. Alright, so to find the particular solution, that means I'm just like taking the integral of this. I'm trying to find the antiderivative. So here's where I am. We're going to do u-substitution. So it kind of looks like 4 minus x squared would be my u, just because it's kind of on the inside there. And then if I find du, the derivative with respect to x, that's going to be negative 2x. So I have du equals negative 2x dx. And then I'm going to do some replacing. So clearly I need a negative 2. There's not one there in the problem. So I'm going to add a negative 2 in here next to that x as best I can. And so that means I need a negative half on the outside of my integral. Okay. So if I substitute, I'm going to do it down here. I have a little more space. I have negative 1/2 the integral of u to the 1/2 du, just to make sure we're good on all of the substitution. So notice that du is negative 2x dx. So there's negative 2x dx, so that becomes du. And then u was negative 4 minus x squared, which is right there. And then the square root is the same thing as the half power. So that's why I have this substitution. Now I'm just going to go ahead and actually take the integral, which would be u to the 3/2 over 3/2 plus c, and I'm going to simplify that a little bit. So this is 2/3 u to the 3/2, and if I multiply those, I'm going to get negative 1/3 u to the 3/2 plus c. Now we do actually have some information because we do have a point way back up here in the beginning. I know that the original function goes through the point 2, 2. So I need to, I think it was 2, 2. Hold on, let's see. Yeah. So it goes through 2, 2. So I'm going to like actually do the substitution here. Instead of writing u, I'm going to write what my u was, which was 4 minus x squared. And that's the equation, but remember I actually do know that it goes through the point 2, 2. So I'm actually going to erase that y and the x, and I'm going to put 2, 2 in there. So 2 equals negative 1/3, 4 minus 2 squared, 3/2. Okay, well that's super convenient because obviously this is 0, and so I end up just getting 2 equals c. So the answer for the particular solution would be that y equals negative 1/3, 4 minus x squared raised to the 3/2 plus 2. Okay, I think I'd like to do number 37. Somebody asked me for 37. Someone also asked me for 23. And even though 37 has trig in it, both 37 and 23 kind of have this like 1 over x thing going on, and I feel like that's really common. So I'm going to do 37. So there's nothing wrong in trying to pick a u and then realizing it doesn't work and trying to do something else. I'm going to go with 1 over theta as my u, just because it's like in the cosine. Remember, this is the same thing as like theta to the negative 1 power. And theta is just a variable. So if I find the derivative of u with respect to theta, it's going to be negative theta to the negative 2, because I'll have to subtract 1 from the exponent, bring it down. And notice that that is actually the same thing as negative 1 over theta squared, so that's convenient. So du equals negative 1 over theta squared d theta. So let's do some substituting. If I look back at my original problem, it does not have a negative, so I'm going to put a negative here in the front, which means I need a negative on the outside as well to counteract it. And now I can substitute. So I'm going to have the cosine of u du. Again, this whole thing is there, and that becomes du. The antiderivative of cosine is sine, and there was a negative in the front, so I'm going to have sine of u plus c, and then I'll just go ahead and plug in what u was, which was 1 over theta. So that's the final answer right there. Another trig one that I could do really quickly, just because there's not a whole lot to it. It looks complicated, but it's not. You do have to think for a second about what your u would be. I know that the derivative of cotangent is negative cosecant squared, so I would be tempted to make cotangent my u. Also, I can kind of keep in mind that this is the same thing as like cosecant squared times cotangent x to the negative 3. Like those are the same things, and so it makes it a little more obvious, I think, that cotangent is going to be my u. So if I make cotangent be my u, then du dx is negative cosecant squared x. And again, kind of like last time, it looks like I'm just missing a negative sign, so I'm going to put a negative in front. There and there. And now let's substitute. So I have negative integral of u to the negative 3 du. So replace all of that with a du. And if I do power rule, it's going to add 1 u to the negative 2 over negative 2 plus c. The negative and the negative will cancel out here, and so I'm just going to end up with cotangent to the negative 2 plus c. If this is a multiple choice question, you would probably more likely see it written where it's down on the bottom, like that. I realize that's not the answer that they have in the book, because they converted 1 over cotangent squared to just tangent squared. Oh, I just realized I lost my 2 when I looked back at it. So if you look back over here, there was a 2 on the bottom. So that should have been a 1/2. So there should be a 2 in front of that cotangent. So anyway, they changed it to 1/2 tangent squared. And then for some reason they changed that to secant squared. But I don't really know why you would need to do that. We can just leave it there if you want. Okay, I'm going to do 2 or 3 more. I think that 51 would be a really good one to do, because I saw a few different questions that involve square roots, and I know that this one is particularly gross because we're going to have to do a change of variables, and so it seemed like when I was walking around, ones that had to change of variables were giving people issues. So let's try this out. There's going to be a lot of algebra in this one. So u is going to be 2x minus 1 because it's in the square root down below, which means that du dx is just 2, or du is 2 dx. So I need to multiply a 2 in here, which means I should have a 1/2 in the front. And if I substitute everything in, we notice that I still have this x squared minus 1 going on. And so I need to do a change of variables for that x. So I'm going to go back up to my original equation with the u and solve it for x. So I have u plus 1 divided by 2 equals x. And I'm going to substitute that in. Okay. I'm going to have lots of like simplifying to do here. So eventually I'm going to take this u to the half that's on the bottom and move it up top, but make it a u to the negative half. But right now let's deal with this. There we go. This guy right here. We need to actually square that out. When you square a fraction, you square the numerator and the denominator. So the denominator is just going to become 4. But with the numerator, we're going to need to actually square it out. So you either need to write it out, or you can do the pattern of square, square, multiply, double, which is what I would do. So I'm going to go ahead and put the 1/4 in the front. So it's like I've squared the 2 on the bottom and have a 4 on the bottom now. And if I do the pattern, I'm going to end up with that. So again, I squared the u, and I squared the 1, and I multiplied them, and I doubled them. So square the u, square the 1, multiply, double. At first glance, it kind of looks like we might be able to cancel the plus 1 and the minus 1, but we need to remember that that 1/4 is in the front. So there's a couple of different ways we could approach that, but we could distribute it in just to make sure we do it right. So I have 1/4 u squared plus 1/2 u, because 1/4 times 2 would be 1/2, plus 1/4 minus 1, and all of that is going to be times u to the negative half. Okay. I'm just rewriting this. I can do 1/4 minus 1 and get minus 3/4. I need to multiply everything by u to the negative half. So I'm going to have 1/4. So remember, if I'm multiplying things that have the same base but different exponents, I add the exponents together. So this is going to become 1/2 of u to the 3/2 plus 1/2 u to the negative 1/2 minus 3/4 u to the negative 1/2 du. Sorry, I just realized this middle term should be a positive 1/2 right there. So I did negative 1/2 plus the squared and the 1 to get that. I don't know about you guys, but the fraction in the front is kind of bothering me. You totally could factor out a 1/4 if you wanted to make the fraction go away. You don't have to. Maybe we'll just leave it how it is for now. But you could factor a 1/4 out if you wanted to. Alright, so if I actually take the antiderivative of this, I'm going to leave the 1/2 out on the front. I have 1/4, and then this is going to become u to the 5/2, because I need to add 1 to it, and then it's going to be multiplied by 2/5, because it was originally divided by 5/2. So multiply by 2/5. Plus 1/2, and then this is going to become u to the 3/2, and that'll be times 2/3, minus 3/4 u to the half, and if I divide it by 1/2, that's the same thing as 2/1. C. And I'm really hoping I didn't do anything silly with my fractions here. So I'm trying to be careful. So if I were to multiply the first two terms together, that 2 and 4 would, like 2 divided by 4 would end up giving me a half. So I'm going to have 2 times 5, so I'll have a tenth. So I'll have u to the 5 halves over 10. Plus, and those 2's will cancel. It looks like u to the 3 halves over 3 minus 3 halves u to the half plus c, and then multiply a half times all of that. Okay, I'm also going to go ahead and plug in what my u was. So my u is 2x minus 1. So I have 2x minus 1 to the 5 halves over 20 plus 2x minus 1 to the 3 halves over 6 minus 3/4 2x minus 1 to the half plus c. Your book definitely has a different answer than this, but I think it's just because they factored some things out to try to make it prettier. But I'm pretty sure that this should still be the right answer. So then I had a couple of questions on ones that had bounds. 59 and 61 were the common ones. I think I'd like to do number 61 because if I do all of them, it's going to take forever. So hopefully you're still watching and learning. But this was number 61. So it looks like the u is going to be 1 plus the square root of x, which is the same thing as 1 plus x to the half. I'm guessing that because it's inside the parentheses of the squared on it. So let's see if that works. That would make du dx be 1/2 x to the negative half. So du is 1 over 2 square root of x dx. So I just kind of rewrote x to the negative half, put it on the bottom. Notice that 1 over the square root of x actually is part of our original equation, and so is the dx. So we really just kind of need that 2 on the bottom, which if I need a 2 on the bottom, that's really like I'm multiplying it by 1/2, which means I should multiply the front by 2. So I'm going to have 2 and then the integral of 1 over u squared du. And that's the same thing as u to the negative 2 du. Now notice I very purposely did not write the bounds. Once I changed it to u's, I didn't write the bounds because technically, and they'll get you for this on the AP exam, the 1 to 9, those are x bounds. So I don't want to write them on my new integral with u because those bounds don't apply. I can, however, find my new u bounds from using my equation up there. So the original bounds were 1, and if I plug in a 1, I get 2. And then the other one was 9, and if I plug in 9, I get 4. So it looks like I'm going to evaluate my new integral from 2 to 4. Those are my new bounds. And the thing that's nice about new bounds is that I don't have to do substitution anymore. I can just evaluate this integral as it is. So there's a 2 in the front. I'm going to add 1 and then divide by that. And I'm going to be evaluating this from 2 to 4. So notice I did not plug the x's back in. So negative 2, this is the same thing as negative 2 over u, by the way. So I'm going to have negative 2 over 4 minus negative 2 over 2. So obviously that will turn to a plus. So I get negative half plus 1, and that equals 1/2. And that does work. That's correct. Okay, the next one we're going to do is 65, and they ask you to find the area of the region. And they gave you a nice little picture of this graph, but you don't really have to have it to be able to solve this. Also, just a note that 3 right there in the equation is a part of the root, to cube root. So I'm going to make u be x plus 1. That means du dx is 1 So du is 1 dx. I can tell pretty quickly that if I was to plug in things here, I still have an extra x there. So the x plus 1, the cube root of x plus 1 is the same thing as u to the 1/3. I need to go back to my original u equation and solve it in terms of in terms of u, like at the x alone. So in terms of u, I have u minus 1 equals x. So I'm going to have the integral of u minus 1 times u to the 1/3 du. And then I'm going to actually distribute that u to the 1/3. So I'm going to have u to the 4/3, because I have to add my exponents, and there's a 1 there, minus u to the 1/3 du. Notice I always put parentheses around my integrand, because I am not, like, I'm taking the integral of the whole thing, not just part of it. I would like to go ahead and redo my bounds so that way I don't have to worry about the 0 and the 7 in terms of the x. So remember that originally I was told that u equaled x plus 1. So if I plug in the bounds, so I'm kind of doing it in the corner here. If I plug in the bounds, which were 0 and 7, so u is going to be 0 plus 1. So I have 1. And if I plug in 7, I get 8. So it looks like my new bounds are 1 and 8. So if I take the integral of that, okay, I'm going to add 1, which would be 3 over 3. So I'm going to have u to the 7 over 3 over 7 over 3 minus u to the 4 over 3 over 4 over 3. And I'm integrating this from 1 to 8. I'm going to clean up these fractions a tiny little bit so we can kind of tell what's going on a little better. This is 3/7 u to the 7/3 minus 3/4 u to the 4/3 from 1 to 8. So I'm going to plug in 8. And notice I'm plugging in 8 into both things. So there's me plugging in 8. And I'm going to do it again, except I'm going to plug in 1. And they usually try to give you things that you can do without a calculator for this kind of problem. The test is going to be no calculator. Okay, so remember when you have a fractional power, that's a root. So this is kind of saying the cube root of 8. So the cube root of 8 is 2. So the cube root of 8 is 2, and then 2 to the 7th power is 128. So I have 3 over 7 times 128. Minus 3/4. So again, the cube root of 8 is 2, and then 2 to the 4th is 16. And then over here, 1 to any power is still going to be 1, so I'm just going to basically end up with 3/7 minus 3/4. This doesn't divide evenly, so this is 384 over 7. This is 12. And then 3/7 minus 3/4. And if I do all of that, I end up getting 1,209 divided by 28 is my final answer. If you find that you have more questions than the ones that I did, please definitely come see me next week before school or after school so we can go over things.